Greetings everyone. Today we're going to explore solving log equations with our log properties for expanding and condensing. So all of our previous lessons will be tied together today for the whole reason of solving for x. Get out your notebooks and a calculator will be helpful as well. All right, let's talk about the types of log equations before we get going. First of all, you have the type of logs where you have a log on both sides. So an example could be something similar to this. When we have that one-to-one relationship where it's balanced, think of it, the equation as a scale. When it's balanced, we can drop those logs and solve for x. We've had equations with a log on one side. So for example, if I had this, we had to convert to exponential. So the base became the base, the answer the exponent, what's remaining became the answer, and we solved that way as well. So now this is what's going to be new, multiple logs on one side. So for example, if I had something like this, now I do not have a one-to-one relationship, I have a two-to-one, so I can't drop the logs just yet. So we need to take care of this addition using our condensing and expanding skills to solve for x. So let's do a quick review. For an example such as this, for solving with logs on both sides, again, we are balanced. I have a log base 5 on each side. So I'm going to drop the log base 5, and I'm left with a multi-step equation from Algebra 1. We're going to add that 7 over, subtract the x over, divide. And with problems like this, you still have to check your answer. So remember, we can't take the log of a negative number, so it's important to check. So if I plug this in, I'd have, let me try that again. All right, we'd have log base 5. If I plug in 4, I'd have 16 minus 7. If I could do that right away, feel free to do that. I'd have 4 plus 5. And again, I see that would be 9. I'm taking log base 5 of 9, which is a positive number, so I can do that. So it checks out. This is again a review. We did a whole lesson and a whole video on this before. So here our option is we only have one log. So I need to convert. So I'm going to go from log to exponential. So the base becomes the base. The answer becomes the exponent. Therefore, what's remaining has to be the answer. The third move, if you will, sort of just falls into place. So let's take care of 2 to the 5th. We end up with 32. Add that 6 over, x equals 38. But we need to check our work. So if I plug in log base 2, 38 minus 6, that would give me log base 2 of 32. If I convert it, base, exponent, 32, so that checks out. Or if you'd like to use your calculator, you could check using change of base formula and make sure that this also gets you to 5. So either way you check, you should know if you're right or not. All right, here's a new example. So very important here. If I look, my equation is not balanced. I have 2 logs on the left, and that's not very helpful. I need to either make it balanced or 1 log so I can convert. Okay, those are my 2 options really. If you can make it balanced logs 1 to 1, or if you can have 1 log so you can convert to exponential. So in this case, I see that I am adding logs. So using our product property, we can start off by converting that to multiplication. So we would keep the base 4, but now I'm going to have x times x plus 12. And we just bring this down, it's still equal to 3. I'm not going to deal with the right side yet. So here I have a binomial times a monomial. I have to distribute that x to both sides. I have log base 4 of x squared plus 12x, still equal to 3. Now I have one log. So my option on this case is to convert to exponential. So the base becomes the base, the answer the exponent, what's remaining is the answer. All right, this looks a little bit like a quadratic, so let's kick that 4 to the third over to the other side. Take care of that. It's going to look like we need to factor. Oops, that should be a negative 64 because I'm subtracting it over. All right, so let's do some factoring. Negative 64 and 12. If you need to pause this video to remember your factoring, please do so because that is an expectation that you factor in each unit. So if you need to, think of the factors of 64. All right, if you need to keep going, make sure that you use your calculator to confirm your answers. If I keep going, let's see, 8 times 8, and then I'm repeating myself. So which of those can get me to a difference of 12? My only option's 4 and 16, but that would have to be a negative 4. So I can jump ahead because my leading coefficient is 1, x minus 4, x plus 16, still all equal to 0. Therefore, x equals 4 or negative 16. But as always, with every example, we need to check our solutions. And often with two solutions, they can both work. One can work, none can work. So we have to make sure we're on the right track. So if I take 4 and I plug in 4, I'd have a log base 4 of 4. So I'm just going to do a little bit of side work here. Plus log base 4 of 4 plus 12 would be 16, and that should equal 3. So if I use my calculator and checked a few things, that looks like it should work out. So try that in your calculator. Let's take a look here. If I take log base 4 of negative 16, hold up, don't even continue. You can't take the log of a negative number, so that negative 16 is already out. Okay, so don't waste your time with figuring out the rest. Now, if you were to check here, log base 4 of 4 is 1. If you were to check out log base 4 of 16 would be 2. And then this would give you 3, so that checks out. Okay, so look for those giveaways. When I plug in a number, am I taking the log of a negative number? That's a dead giveaway that you don't need that answer. All right, let's take a look at just a couple more examples. Again, my options are to get balanced logs, meaning one-to-one relationship, or narrow it down to one log. So in this case, I see that I am subtracting logs. So using my properties for logarithms, I can change that subtraction sign, and I'm now going to have log base 2 of 5 plus 2x over 4 minus x. Whatever comes first is in the numerator. Whatever value is second is the denominator. And still all equal to 3. Yes, it's a little bit busy, but I've narrowed it down to one log. So now I can convert to an exponential equation. The base of 2 becomes the base. The answer becomes the exponent. What's remaining becomes my answer. So 2 to the third, let's take care of that. I now have an equation equal to 8. This is kind of messy. I am currently dividing by 4 minus x, so I'm going to do the opposite, the inverse operation, and I'm going to multiply by 4 minus x. So that's going to take care of the right side. 8 times 4 minus x, I need to distribute. So I'm going to have 32 minus 8x equal to, I still have that right side in the numerator that I have not used. So what started off messy has ended up being a pretty straightforward Algebra 1 multi-step equation. So I'm going to subtract that 5 over. So I'm going to get it down to, let's see, what do we have? 27? Does that look right? And then I'm going to add that over. So I'm going to have 10x. All right, now I'm going to divide by 10. So I have x equals, and I'm going to leave it as 27 tenths. You could divide as well. It might be easier to type into your calculator. Whatever's easiest, because it's terminating decimal, I say why not. But I still need to check my answer. So log base 2 of, and I'm going to take care of this calculation straight into the calculator. 2 times 2.7 plus the 5 gets me to 10.4 minus log base 2 of 4 minus of the 2.7, take care of that right away, 1.3 equal to 3. A couple of options, you could take that subtraction using your properties, make it division. I'm just going to plug this straight into my calculator using change of base. So I'm going to do log of 10.4 and divide that by log of 2. And then I'm going to subtract, and I'm going to take that log of 1.3 divided by that log of 2, and I get exactly 3. So use your calculator to your advantage to make sure that you are correct. All right, let's take a look at one more example. In particular, this one can confuse a lot of students. You'll notice it looks like I'm balanced. It looks like I have a log on each side of the equal sign, but I also have a -1. So that is not balanced. So we actually have to make it look like the previous examples. I want to be able to combine these log values. So you have a few ways you can do that. I'm just going to actually subtract this log base 5 of 10x to the other side. So I'm going to create a subtraction problem. Now it actually looks like the previous example. So I'm going to take that subtraction, and using my properties, that's going to become division. What's first is in the numerator, what's second is in the denominator. I have a single log, so now I can convert. So I'm going to take base to base, answer to exponent. What's remaining is your answer. 5 to the -1 is the same as saying 1/5. Hey, take a look at this. Now, let's say you didn't like that negative exponent. You could have added the 1 over and subtracted the other log to the other side. If you want to keep that constant positive, then do what work you need to do to make that happen. But in this case, I have a fraction equal to a fraction. This is the only time you can cross multiply is if there's an equal sign. Okay, very often confused with addition and multiplication rules. So because it's equals, I can say 1 times 10x equals 5 times 3x minus 1. So I can go ahead, simplify this multi-step algebra 1 equation, kick that over, divide, I get x equals 1. Seems a little too good to be true, so let's check our answer. Log base 5, 10 times 1 would be 10. Log base 5, 3 minus 1 would give me 2. Again, feel free to just use your calculator. You could use some properties to narrow that down as well. I'm going to plug that straight into my calculator using parentheses carefully, so please watch out for that. So I'm going to take log base 10 divided by, excuse me, not base 10, log of 10, oh my goodness. And I'm going to divide by log of 5, and I'm going to subtract 1. So that gives me a crazy decimal on the left side, but that's okay. What matters is that I have the same crazy decimal on the right side. So I'm going to take log of 2 and divide by log of 5, and I conveniently get the exact same crazy decimal, and therefore I know I am correct. X equals 1. So that's the best part about this section, is because we're solving, you should be able to confirm every answer on any quiz or assessment coming up. So moving ahead, make sure you check Google Classroom to see what your assignment is. As we prepare for any upcoming assessments, let me know what you need help with. Prepare, study, watch previous videos, and we'll see you next time.